Hello students, let's continue the topic of remote sensing. The first type we were understanding is satellite remote sensing. As we have understood earlier, satellites are man-made vehicles which will carry the sensors like camera to a very high altitudes to gather the information about the Earth. Satellites are generally equipped with sensors or cameras of one or many, and they are placed in the imaginary path surrounding the Earth, which we call it as orbits. Hence, these are called as remote sensing satellites. Satellites are generally sent to specific orbits of the Earth in space, which would be around 600 to 1000 kilometers away from the Earth's surface. Orbits are the imaginary paths around the Earth for satellites. There are three types of orbits that are used in satellite remote sensing. The first type is equatorial orbit. The second type is geostationary orbit, and the third type is sun-synchronous orbit. The first type is geostationary satellites or orbits. In geostationary satellites, the rotation of satellite as well as the Earth will remain same, because there is a fixing of position for the satellites to collect the information of the geographical area on the Earth, which is also fixed. So, position of satellite is also fixed to gather the information of a particular area on the Earth. So, this kind of satellites are used in widely used in collecting the information of the weather, and even in communication satellites the technology of geostationary satellites are used. Students, remember here, rotation period of the satellite as well as the Earth will remain same, that is of 24 hours. The second type is equatorial orbits or satellites. Here, the satellites are placed in the orbits which are inclined to 57 degrees from the equator. Thereby, the information what the satellites gathers gets slightly altered, and this is widely used in space shuttle satellites. The third type is sun-synchronous satellites. Here, the orbits are localized from North Pole to South Pole. So, polar orbits are seen here. And here, when satellites are placed in this orbit of polar of north to south, it shows the inclination which is very high and synchronous to the sun movement. And this is widely used to gather the information about the polar locations of the Earth. Widely, satellite remote sensing is used in gathering the information about a land, coastal area, oceanic systems, then forests, atmosphere, climate changes, then ecological health of a particular area, then deforestation details, ecosystem degradation, and if any changes are happening in the forest, such information can be recorded by using satellite remote sensing. Here is a slide that depicts the wider applications of remote sensing. Here I would like to highlight one point, student. We are going to understand applications of remote sensing in detail in one more class, but here I am going to give the bird view of the applications of satellite remote sensing. First, we will start off with usage of satellite remote sensing in geosciences. As we know, satellite remote sensing is widely used to collect the information about the Earth. We call it as geographical information, such as they gather the information about the water resources, we call it as hydrology. It can get the information about the marine and oceans, we call it as oceanography, which is in the form of a scientific drawing, which we call it as a cartography. Next, it is widely used in the development and construction fields also. Urban development and engineering of construction can be done, or information can be gathered by using satellite remote sensing. It is also widely used in the conservation and research aspects and fields, such as wildlife conservation, marine conservation, archaeology, etc. The satellite remote sensing finds its application even in defense and intelligence field also. It helps in mapping the defense areas such as line of control, and even target tracking can be done by using satellite remote sensing. It is also used to gather the information about the natural resources, such as details about a forest or agricultural field, coastal area, environment, atmosphere, etc. Satellite remote sensing finds its application in collecting the information about the global warming research field. It gives the details about the temperature of a particular location, the climatic conditions of a particular location, then the areas of the glacier regions, their changes can be recorded here. It is also useful in gathering the information during the disaster time, such as it gives the details about the floods, landslides, earthquakes, forest fires, etc. The other application is it is widely used in monitoring the traffic system both on the land as well as in the air. So, these are all the important applications related to satellite remote sensing. Students, remember satellite remote sensing can work when the atmosphere is free from that of three important factors. Number one, clouds. If clouds are there, satellite remote sensing does not work, radiations cannot penetrate. If dust particles are there, the satellite remote sensing does not work. If there are any chemical particles or hazy particles in the environment, atmosphere, the satellite remote sensing does not work. These are the drawbacks related to satellite remote sensing. Students, now we shall understand the second type of remote sensing, that is microwave remote sensing. As we have seen, the drawback related to satellite remote sensing is it does not work during the cloudy environment or climatic conditions. If the atmosphere is filled with the hazy and dust particles, this satellite remote sensing does not work. Then what is the better alternative for it? It is the second type of remote sensing, which we call it as microwave remote sensing. Microwave remote sensing is widely used during the climatic conditions when the atmosphere is filled with the clouds and hazy particles or dust particles. It is because the wavelength of the electromagnetic spectrum, what it uses is between 1 mm to 1 m, that is 1 millimeter to 1 meter of wavelength is the microwave spectrum is of. So, it is widely used during this disturbing climatic conditions. And microwave remote sensing is widely used even during the rainy seasons and rainfall conditions. So, that is about the importance of microwave remote sensing. There are two types of microwave remote sensing. which is referred as passive and active. As what we have recorded or seen in the satellite remote sensing, same type here also. This is purely based on the source of energy which emits the radiations. In passive microwave remote sensing, we find EMR is emitted by the Earth's surface itself. So, which is having the wavelength of 0.5 centimeters to 30 centimeters. So, this kind of a natural resource which emits the microwave electrospectrum is very small in their range, and thereby what the information it can gather, it is not that clear. So, resolution is affected of the pictures or information what they gather from passive sensors. So, Earth is the passive sensor which will emit the radiations of microwave, and the sensors will record it, no doubt, but the information what they gather will not have a very proper resolution. So, it will be very hazy, a kind of disturbed resolutions it will have. The second type we have is active microwave remote sensing. Here the same source acts as emission of microwave and the sensor here, that is collection of information. In active microwave remote sensing, we make use of the radar type which we call the synthetic aperture radars. They are very sensitive and very powerful, and they can get the information both during day and night times, and the clarity, that is the of the information of the object what they get is, it's very specific. The drawback of microwave remote sensing is that of a very large area, if it needs to collect the information, it will show lesser resolutions, lesser clarity. If it is of a very small area, the information what they gather will show very good resolution. So, this is about the importance of microwave remote sensing. Fine students, I think I have made the concept of definition of remote sensing, types of remote sensing, namely satellite remote sensing and microwave remote sensing clear. If you have any queries, you can call me or chat with me using the WhatsApp number that I have posted to you. And these questions of types of remote sensing could be asked for 10 marks together. Each of the type could be asked for short notes. Thank you all. We shall continue the class with the application part of it in the next classes to come. Happy day ahead, students. Thank you.